viewers, welcome to my channel. So in this video, we'll discuss about the user-defined data types. As we have int, float, double, and other basic data types. Similarly, we have a data type that depends on the user. So how much memory they want to give actually to that data structure. So all the basic data structures have their limited space as allocated by the system, but here we can increase or decrease the size of that variable, that user defined variable. So let's see how we can do it. So in this video, we'll discuss about these 5 points. So let's define the structure first. So structure is defined by using a keyword struct. Then we have the name of that structure, the memory to which this structure is pointing, and then we have the curly braces and the semicolon, and in between we have various basic data types at int and double I have taken, and x, y, z are the variables that is inside this structure. So this user defined data type consists of these three members. Okay, so by declaring this structure, we are not providing the memory to it. Okay, so memory will be provided to this structure only when we define an object to this structure. Okay, so how can we do that? So we have this struct point, name of the structure, and then we have the object as p1. Okay, so this way I can allocate memory to this structure. Okay, so once the memory is allocated, we need to access the members within the structure, that is x, y, and z. Okay, so once this memory allocated, we will print the values, the default values of this structure, what is inside. So if I take printf, the p1 dot x, so by using a dot operator, we are accessing the member of this structure to this object p1 dot x. Okay, so it would be percentage d, as it is an integer, x is integer, and p1 dot y is also an integer, so we'll take it percentage t. And then we have p1 dot z, that is of double type, so I'll take percentage lf. Okay, then I next line is there, then we use p1 dot x comma p1 dot y comma p1 dot z. Okay, let's save it and let's compile it first. So let's run the binary now. Let's see what is the output of this print. Okay, so we are getting the value 8 minus some value and 0.0 something on z. So this is the default value. So this is just a garbage value that is present in this memory. So we are accessing this memory. So the second part will be the initialization of this object. So while using this representation, we need to make it null first, so that there no error in the program, and there is the error values are not used or the garbage values not being used. Okay, so let's save it and then run it quickly. Okay, so all the values, x is integer 0 0 and z is a double, so it's in that decimal notation. Okay, so next, how to initialize this variable to a default value. So sometimes we need some default values for that variables. So what we'll do, we'll take a sequential order. For example, first one is integer x, second one is double z, and third one is y. So we will take accordingly, like we have y value for x, then we have 7.5 for double, and for z it is 9. Okay, let's save it and run it quickly. Okay, so we'll get 5, the value of x, 9 for y. So y is the third one, okay, but here we are using in the second place. And for z is 7.5 and 5 zeros. Okay, so this way we can initialize variables, but this is a sequential order if you see. So 5 x is the first memory, we assign 5, z is the second, and y is the last one. So if we don't need to remember the sequential order, and if you want to initialize this structure, there is one more way. In this way, what we will do, we will take dot x as a notation, and we'll assign, this time we'll take 6, then we have comma, then we have dot, we'll take y now. Okay, so it would be 8, and third is z. So z dot z is equal to 8.5. Let's see what is the output now. Okay, so here we'll get the x value as 6, y value as 8, okay, and z value is 8.5. So this way we can initialize the structure, and this allocation can be done in the global scope as well. Okay, so if you take it till here, and if I delete from here, so still if you see, we are able to compile it. Okay, so this is uh, the scope of this structure variable. Okay, so there is one more way how to define this p1 variable. So what we can do is, uh, we'll take this, compile it again, you will get the same result. Okay, so next is, you can define multiple objects here. So we have two objects p1 and p2, and we'll assign a value here as well. So in place of, here I'll take p2, here I take p2, I'll take here 9.5, I'll take 7 here, and I'll take 10 here. Okay, so similarly I'll print the p2 value like p1. So here I'll change to p2, p2, p2. Here also, as we have the same name of the variable in p1 and p2, so here we'll get p2. Let's save it, let's compile it. So here you can see the value of the structure p1 and p2 is here. Okay, so the last point is how to copy one structure into another. Okay, this can be done by p1 is equal to p2. We'll assign the value of p2 to p1, and let's see what is the output of this. So here I need only p1, so I will comment it out, I save it. Again I go here and I compile it. Okay, you see here it is 7, 10, and 9.5. But the point here is, like, these are only variables. Okay, so this value is being copied into the second variable. So if we have pointers here, the address of the pointer is going into the second variable. So if we won't delete the first structure, it would create a problem for the second as well. So we should keep in mind while using other form of variables. Okay, so this is how we can use a structure in our program. Thank you, have a nice day.